All right, everybody, welcome to the video of January 2023's Regents exam, part 1. So in this video, we're going to go through some test taking skills, go over a couple of the part 1 practice questions. Hopefully it's a good way for you to check the work that you've already done. So a couple things about this video. There might be a couple questions that you haven't not gotten to yet. I know for my class, there's a few units that, like especially the statistics stuff. So if I'm doing something that you just haven't seen before, it probably just hasn't been taught yet. So let's just jump right in. So number 1 wants us to know which is equivalent to this expression. So the way that they want us to do this question is to essentially rewrite this quadratic as something else. So like say like a squared minus 5a plus 6. So essentially we're saying that a is x plus 2. And then we want to try and factor this like normal. So we're saying what multiplies to make 6, but adds to make negative 5. And we know that's going to be negative 3 and negative 2. Now, that's not my answer because a is really x plus 2. And a is really x plus 2, which is going to make this x minus 1. And it's going to make this just x, which gives us choice 1. Now, there are other ways of doing that problem. Like you could have multiplied out the original expression and saw what it was equivalent to. You also could have just graphed it. So where they intersected the x-axis and graphed your 4 choices and saw which one was the same. But that would be the algebraic way of doing that one. All right, so for number 2, we have this equation. It has e in it and the variables in our exponent. So if this was a part 2, 3, or 4, we'd instantly start doing algebra. We'd add our 123, we'd divide the 4,300, we'd natural log a bunch of stuff. But we know that we don't have to do anything like that because it is an equation in part 1. So if it's an equation in part 1, we're going to make 2 equations. We're going to make 4,300 e to the 0.07x minus 123. And we're going to make our second equation, which is 5,000. And we are just going to graph both of them on Desmos. So if we make a little Desmos tab here, and we graph these, let's see. I got to get rid of this stuff. Okay, so I'm going to graph y equals 4,300 e to the exponent of 0.07x, and then get out of my exponent to put minus 123. And then I'm going to graph y equals 5,000. And I'm just interested to see where they intersect. So I'm going to adjust my y-axis because 5,000 is a really big number. And I'm going to click where they intersect. And it happens at around 2.5. So my answer is 2.5. Pretty easy first question. Well, second question, sorry. Obviously, like I said, you could do it algebraically, but why? All right, number 3 is really just talking, do you know how these exponential functions work? So we have this automobile being purchased, and the base number is 0.84. You have to remember the base represents 1, either plus or minus the rate. Since it's smaller than 1, it's going to be minus. So if we solve for r, we can say the rate is 0.16. So this car is going to decrease by 16% per year. Okay, number 4 is another graphing question. Yes, there are rules to determine which of these is exponential decay, but since it's multiple choice, I want to just graph them all. So if I start graphing them, I'm looking for one that's going to decrease, right, from left to right. So if we go to Desmos again, clear what's in there. I'm going to hit the home button because I don't think we need up to 5,000 for this one, but we'll see. Instead of p of x, I'm just going to use y to make my life easy. And we'll put in our 1/4. And we'll put it to the exponent of negative x. That is an increasing function, so that's not right. And then we'll put in our second choice. So we'll say 1.8 to the exponent of negative x. And we'll see that's a decreasing function. If you really want to test the rest of them, you can, but the second answer there is choice 2. Moving right along to number 5. Number 5, there are two ways of doing this question. The way that I'm hoping that you chose to do it, if you tried this on your own, was using the remainder theorem and knowing that when you divide by x plus 2, that tells you that whatever the function is, we'll just call this f. So if f of x is x to the fourth minus 5x squared plus 4x plus 14, the remainder is going to be f of negative 2 is going to equal the remainder. Now, if that's 0, that means x plus 2 is a factor, but what we can see here is all of them have a remainder, and all the remainders are different, so the remainder theorem is going to be the easiest way to solve this. So if I plug in negative 2 to the fourth, minus 5 times negative 2 squared, plus 4 times negative 2 plus 14, we get a value of positive 2, which tells us the remainder is positive 2. I don't even have to do the division. If you really wanted to, you can make your boxes, you can do the whole thing and put x plus 2 here and try and create this, but why do all that extra work if you don't need to? Number 6 gives us a series. So this is a sum of some type of a sequence. It asks us for the first 20 terms of that series, and we notice that this is geometric in nature, right? We know the first term is negative 2, and to get from one term to the next, we're going to multiply by negative 3. So when I find the series formula right on our reference table, which should be on the first page of your book, we have negative 2 minus negative 2 times negative 3 to the number of terms we're trying to find the sum of, so 20, and in the denominator, 1 minus the rate of negative 3. Then it just becomes typing that into my calculator. So remember on Desmos, if you want to make a fraction, easiest thing to do is just make a random fraction and then edit it. So go up to the numerator and you can edit that fraction. So negative 2 minus negative 2 times negative 3 to the 20th. And then in the denominator, we could do 1 minus negative 3. If you make that into a nice number, we get that 1 billion number, and that's our answer. Another way we could do this is with sigma. So we can make this 20, and then we can come up with an explicit formula for that geometric pattern. Type that in, you'll get the same exact answer. Those are both the same. All right, moving on to number 7. So number 7 asks us to find the value of f of 1/2 and then tell us what it means. So first things first, I got to plug in 1/2 to that equation. So if we do 2 times 1/2 to the fourth, and again, you're typing this in the calculator exactly how you see it with the parentheses and everything. It's the nice thing about Desmos, just make it look the same. We get 0. 0 tells us that it is a factor, right? So it equals 0, so that means it can't be 3 or 4. Now, when we say it is a factor, we're talking what is a factor. So that means x equals 1/2 is a solution. To make a factor, I need to make this equal to 0. So I can multiply both sides by 2 to make this 2x equals 1. I can subtract 1 and get my factor 2x minus 1 equals 0. That's how we're finding our factor. So choice 2 would be the answer for that one. Number 8 is kind of a tricky question. There's a couple ways I think you could look at this one. What I did when I first did this one, I noticed that I'm squaring a binomial. So I'm going to make some boxes to do my multiplication. I'm going to have 6 minus ki and 6 and minus ki. If I multiply this out, I get 36, negative 6 ki, negative 6 ki, and positive k squared I squared. Now that's going to give me 36 minus 12 ki plus k squared I squared. But we know that I squared is really negative 1, so that whole last term is going to become negative k squared. And then I'm going to focus on the 27. This number and this number together have to equal 27. So if I make k 3, that would be 36 minus 3 squared, which makes 27. So 3 makes this work. If you multiply negative 12 times 3, you're going to get the negative 36i that you're supposed to get. So 3 is the only number there that works once you've done your multiplication. Moving right along. So number 9. Number 9 gives us an equation. To be able to solve this equation, we have to do a common denominator. Before we do anything, though, think about the undefined values. I know, just by looking at this, x cannot be 0. X can't be 0 here or here. So right away, I know it's not choices 2 or 4, because 0 can't be an answer here. Also, my common denominator is going to be 3x. So I want to make every single fraction have a denominator of 3x. The last one already had that common denominator, so I'm going to leave it as is. The first fraction had the x, but not the 3, so I have to multiply this numerator by 3, which can make 3x plus 6. This one didn't have the x, so I have to multiply this by x, so that's going to make this x squared. Well, now that I have a common denominator, I don't really care about the denominator anymore. I'm left with just the equation 3x plus 6 plus x squared equals 2x squared plus 6. If I start moving terms around to make this equal to 0, I get 0 equals x squared minus 3x. Two terms, GCF that guy, and you get x equals 0, which we already know is rejected, and x equals 3. Now, since this is multiple choice, you have to remember too, the answer is right there in front of you. So if you are eliminating the zeros because you remembered the undefined part, you then can plug the two other choices in and see which one works. For number 10, it asks how many real solutions exist. So real solutions are going to be intercepts. So I want to see how many times that these two equations intersect each other. So I'm going to go back to Desmos here, and I'm going to graph my two equations. So the first one was y equals 1/4. I forgot the equal sign. There we go. 1/4 x minus 8. So we get this linear function. And we get y equals 1/2 x squared plus 2x. And I want to kind of expand. So I see that these two are never going to intersect. So there are no real answers. Number 11, you could do two different ways. You could either do the crazy way, which would be multiplying everything out, or you could just remember your rule, right? We know that these are the sum of two cubes. The sum of two cubes using that idea of SOAP, same, opposite, always positive. And in class, what we did when we did this was like a cubed plus b cubed is equal to the sum of the cube roots, the first term squared minus the product of the two, plus the square of the second. Same sign, opposite sign, always positive. So if you just follow that rule, you see the answer is choice 2. Nothing really mathematically to do there other than remember an identity. Number 12, when you're dividing variables, you're going to subtract the exponents. If you subtract 1/5 minus 1/2, you are going to get x to the negative 3/10. Now we know that negative exponents make a fraction. We do the reciprocal thing. And we remember the rule of exponent over root. So this is going to become a 10th root of x to the third in the denominator, choice 3. Number 13 gives us a sine curve. We see it's a positive sine curve with an amplitude of 5. And the biggest thing here is just seeing where one sine curve starts and ends. So it goes up, it goes back down, and then it ends here at 1. So the period of this function is 1. Remembering that period times frequency is equal to 2 pi, we can figure out that the frequency is just 2 pi. And remember, frequency is the number that gets multiplied inside the function to the variable. So this answer is just 2 pi. Number 14 is a sequence question. Statistics question. Looking at this, it's asking us which is the most accurate way of collecting data. So there's a couple of reasons why choices 1 through 3 are wrong. So number 1 talks about a survey about parenting styles, and we want to ask students entering the library and wondering if that will provide unbiased results. That's probably going to produce biased results because of a couple of reasons. One, you're asking students about parenting styles. They're probably going to have a biased opinion on how their parents parent them. You're also asking students to go into libraries, so chances are they're all going to have very similar parenting styles. So that's not really a great idea. Number 2, an observational study allows the researcher to determine cause of an outcome. Observational studies do not find cause or effect. All right, that is just observing and documenting. That's all observational studies are. Number 3, margin of error increases. The sample size must decrease in size. So that is opposite of what we said in class. So choice 4 is the only one that makes sense. Number 15 says to find an inverse. As soon as we see the word inverse, it means switch x and y. So I'm going to rewrite this as x equals 1/2 y plus 2. If we subtract 2, we get x minus 2 equals 1/2 y. Multiply both sides by 2, we get 2x minus 4 is equal to the inverse, choice 3. Number 16 was a tricky question. So the first thing I'm going to do for number 16 is actually graph it. So I'm going to go back to our good friend Desmos here, and I'm going to graph it. So we could call this function f of x. And let's graph it. So we have x to the 4th minus x to the 3rd minus 6x squared. Okay, so here is our function. What this question is asking by saying greater than 0, it's asking us when is this function above the x-axis? When are the y values positive? So looking here, we have positive y values smaller than -2. Then between -2 and 3, the graph is either at 0 or below 0. And then after 3, the graph goes up and is positive again. So we want to choose the choice that tells us all the values of x that are smaller than -2 and greater than +3. Number 17 is another Desmos question. We want to graph both sides here. All right, so we want to make two equations, y equals log of x plus 5 and y equals the absolute value of x minus 1 minus 3. And see where they intersect, right? So if we go to Desmos again, so I'll say y equals, we'll go to functions here. Log should be in functions. We have log, no base here, so it's base 10, x plus 5. And then if we go y equals, absolute values over here above ABC, and we'll put in x minus 1, get out of the bracket by hitting it again, and put minus 3. Again, you can always hit the home button to see your zoom. So we have one intersection, we have two intersections. The x values are what they're looking for here. So negative 2.41 and 5. So that would be choice 3. Number 18 was kind of a tough question because it didn't give us numbers. It gave us variables A and B. So we have to really understand our rules here. All right, so exactly one real root. First off, we need to look at the real parts here and see which one gives us one real answer. So choice 3 would give us two real answers. So it can't be choice 3. Choice 4 is going to give us 3 real answers because it's subtraction. Remember, if you have subtraction of squares, it's going to be 2 real answers. X squared plus b is going to be 2 non-real answers. So choices 1 and 2 both have one real answer coming from x minus a and a minus x, which leads us to the second part of information. They're saying as x gets bigger, the function gets smaller. So that means this cubic graph is going to be something like this. which we know has to have a negative leading coefficient. So now we're trying to ask ourselves which of these two options that are left have a negative leading coefficient, which is going to cause us to multiply x and x squared and produce a negative number, which is choice 2. Now, if that was a confusing one for you, you can choose some numbers for A and B, but make sure you choose the same numbers for all. Like choose A is 2 and B is 5, and graph all 4 choices and see which one has one intersection, one real root, so one intersection, and which one looks something like this, where it's going to end by pointing down. 18 was a tough one. All right, number 19 gives us a simulation. Every time we have a simulation, we're looking here. This tells us how to find the margin of error. Remember, your margin of error is always 2 times the standard deviation. So in this case, we would have 2 times 0.035. So our margin of error is going to be 0.07. That's it. You just needed to know what to do for that. Number 20 tells us that we have a cosine value. Notice it's positive, and this is telling us that tangent is a negative number. So what quadrant are we in when tangent is negative and cosine is positive? We'd be in quadrant 4. So we definitely have a quadrant 4 angle, so I'll make a triangle here in quadrant 4. The sides we know are going to be the adjacent side and the hypotenuse side. If we do some quick Pythagorean theorem, we can figure out that x is going to be 2. So that missing side is going to be 2. Now it comes down to finding the sine of this angle. Well, the sine of this angle is going to be the opposite over the hypotenuse, so 2/3. So it can't be those two. And since we're in quadrant 4, we know sine is negative, so it's going to be choice 3. Okay, so the next one gives us a scenario which can generate a pattern. So it says that the family of trees starts with 150, and each year it decreases by 20. So if I'm decreasing by 20%, right, my rate is going to be 0.80. That's going to be my ratio. That's what I'm going to multiply each term by to make the next term. I'm going to decrease by 20 by multiplying by 0.8. So right away, it can't be choice 1 because that multiplies by 0.2, and it can't be choice 3 because that also multiplies by 0.2. It also tells us that we replant 80 seedlings each year, so we're going to add another 80 to each of the previous terms. Choice 2 winds up being our best answer here because it's saying the first term is 150, the next term is equal to previous term times 0.8 plus the number 80 for the new 80 trees. Choice 4 would be the explicit formula and would have been right if this exponent was n minus 1 instead of just n. Number 22 talks about focus and directrix. This is one of the things we'll do way at the end of the unit. The school year. So we probably haven't done this yet by the time you watch the video. It's not that hard though. So every parabola has a vertex, a directrix, and a focus, and the relationship between them is their equivalent in distance. So if I just make a quick sketch of this parabola, so we have a line at y equals 1, we have a point at 4, -3. The vertex is going to be in between those two, making this parabola open down, because the parabola always wants to try and hug the focus. The coordinate of this vertex is going to be 4, -1. That would be the point in between these two things. So now I want to create an equation that has a vertex at 4, -1. Also, it has a p-value of -2. So the equation is going to be y equals 1 over 4p times x minus h squared plus k, where h comma k is the vertex. So if we create an equation here, we have 1 over -8, because -2 times 4 is -8, x minus 4 squared minus 1. Notice that's not a choice, so we have to manipulate this equation to make it look like my choices. So I'm going to add 1 to both sides. So I'm going to get y plus 1 equals -1/8 times x minus 4 squared. I then can multiply both sides by -8. So we have -8 times y plus 1 is equal to x minus 4 squared. That should be a choice. It is choice 4. Number 23 talks about Mia and her student loan. Right now, her formula for f of x is in terms of the yearly increase of 3.25%, meaning her exponents in terms of years. I want to make it in terms of months. So if I take this rate, I don't care about the initial value. I want to change this rate to be in terms of the monthly rate. So I want to raise that to the 1/12th power so that the exponent on the outside can be in terms of months. So right away, we know it's not choice 2 or choice 4 because it has the wrong exponent. It's also not choice 3 because it has the wrong decimal, because I know just by knowledge of numbers, 1.0325 to the 1/12th power is not going to be 1.0325. If we type it in the calculator, we see it comes out to be 1.0027 rounded. Last question for the part 1. It tells us that we have a quadratic function, meaning it is a parabola. Right away, it can't be choice 3. That is not a parabola. And it wants us to have two imaginary solutions. Imaginary zeros are going to be no x-intercepts. Well, the only graph that's a parabola with no x-intercepts is choice 2. Hopefully you got a lot of these right on your own. The ones that you got wrong, hopefully my explanation was helpful. And I'll see you for the next video. Keep studying.